Hey there, howdy gang. Good to see all of you. Happy Monday to you. I hope that everyone had an excellent, outstanding, fun, athletic, studious, intellectual, fun-filled weekend. That you got to do some of the things that you wanted to do. Today, I'm sorry I couldn't be with you, but we're going to go ahead and do 6.1 anyway, and I'm excited for it. Make sure to take some really good notes today and make sure that on Wednesday your 6.1A worksheet is completed. Tomorrow you're going to have Unit 5 quiz. So make sure tonight to study for that, to look online for all the resources that are available to you. And let's go ahead and continue on. Thank you for being mature and responsible while using the Chromebooks today. I do appreciate that. And I look forward to seeing each and every one of you tomorrow in class. So here begins the section 6.1A notes. If you want to follow along, then continue watching. And the Smartboard file is also available on the website if you want to go ahead and do that now. All right, have fun, enjoy. Friends, if you are interested in following along with these notes, in order to better see the screen behind me, then go ahead and go to my website, Google Degaitis Math, and click the one that's a Cherry Creek High School website. Go to your class, scroll down to the bottom of the notes page. Okay, and right here, I've uploaded the PowerPoint that you will be watching. Sorry, not PowerPoint, Smartboard file that you will be watching that goes along with these slides here. Okay, so if you're interested in being able to better see the Smartboard behind me, then go to the website and open up the 6.1A notes, okay, and you'll be able to follow along the entire time. Go ahead and do that now. All right, cool. So the first question I think that we have to consider is, what in the world is a parabola in the first place? Okay, I'm sure that you've heard that word before, perhaps that you've seen it, talked about it in science class. Maybe you've graphed them before, you know what the shape is, but you don't know where it comes from. Okay, what is a parabola? A parabola, we get the word from basically how objects behave when they're under the force of gravity. Okay, so for example here, we've got our kicker, our Cherry Creek Bruins kicker, right? And he's lining up for his plus 45-yard field goal. Okay, and when he kicks that ball, that football towards the field goal post, that ball is going to be under the force of gravity. And the path that it's going to take is naturally the shape of a parabola, okay? That's the shape that objects will make when they're under the force of gravity. So let's draw one just for the fun of it, just so you have an idea of kind of what a parabola looks like. So when this ball is kicked, it's going to go immediately up into the air, okay? And it's going to follow a trajectory and hopefully go through that field goal sign, all right? What we've just created right here, this upside down U shape, is called a parabola. If we were to put that on an axis, okay, we could have a graph here. And what we have is a parabola, an upside down U shape. Okay? Keep in mind that parabolas, they could be right side up U's, okay, they could be upside down U's, they could be really tall and skinny U's. Okay, they could be really short and kind of wide U's. Parabolas could be any of those shapes. They're affected in different ways by the different variables and the stuff that we add to the equation. Okay, so this is an example that we're most used to seeing in the real world. Okay, an object under the force of gravity sees this sort of parabola here. So within the realm of mathematics, what is the most popular or most common parabola that we will probably see? Let's talk about that. Maybe you think of it, you know it before. What makes lines take curved shapes? You're thinking to yourself, well, if it's linear, if all the x's are raised to the first power, then they're all going to be straight lines. Okay, but as soon as we add an exponent to that equation, maybe we raise it to the second power, then we're talking curved graphs. We're talking exponential graphs. In this case, we're talking parabolas. The most famous parabola we know of today, we call it our parent function. That's the graph of y equals x squared, or in our case, f of x is equal to x squared. Okay? That's the most famous parabola we know of today. That's what we call our parent function, meaning every type of parabola that we'll graph is going to derive or get its shape in some way from this function here. So know that function y equals x squared, or f of x equals x squared. That's the most basic parabola function. All right, so traits of the y equals x squared function, what are they? What are some traits? Okay, what are some characteristics of the y equals x squared function? Let's get an idea of what it even looks like in the first place. All right, how do we get an idea of what y equals x squared looks like? Let's pick some points. Let's plug it in. Let's check what comes out. All right, so I like my 5 x values. I like to sit right around 0. I'm going to go with -2, -1, 0, 1, and 2. I think these might be able to tell me a few of the characteristics of the y equals x squared graph. So plugging in -2 to y equals x squared, well, -2 for x, so -2 squared. To square means to multiply by itself, so -2 squared is -2 times -2, and that's going to give me a +4. Okay, plugging in -1 for x. -1 squared means -1 times -1, and that's +1. And 0 squared means 0 times 0, so that's still 0. And 1 squared, well, we already talked -1 squared, but 1 squared is just 1 times 1, and that's 1. And 2 squared is just 2 times 2, and that's 4. Okay, so let's plot these points on our graph. Let's get an idea of the shape of that graph. I'm going to start with 0, 0. That's right there in the center. 0, 0, right there in the center. 1, 1. If I move into the right, I got 1, 1 here. Okay, moving another step to the right. 2, 4. 2 over 2. Up 1, 2, 3, 4. Okay, and going to the left, -1, 1. -1, 1. Over 1, up 1. And -2, 4 means left 2, up 1, 2, 3, 4. Okay? And we know it's curved, so don't draw straight lines in there. It's not an absolute value, v for value function. It's a parabola. It's curved. It's going to go up. I'm going to put arrows on the end to signify that it goes on forever. Okay, so what are some of the traits of this function? Let's talk traits about it. Let's learn some words here. Traits of the y equals x squared function. Well, one of them is this value right here. It's the bottom. Okay, it's kind of the meeting point of my two lines where they stem from. That's what I call a vertex. Okay, a vertex. And the vertex of my parent function, y equals x squared, is the point 0, 0. Okay, that's one of the traits of the parent function, is that it has a vertex at 0, 0. Other traits, characteristics of the parent function y equals x squared. Well, I notice that it's symmetrical. Okay, it's symmetrical, meaning it's the same on the right-hand side as it is on the left-hand side. Okay, it's symmetrical. Where is my line of symmetry here? Well, my line of symmetry is right down the middle. This blue line that I just drew, that blue line has an equation. It's a vertical line. We know vertical lines have equations of x equals a number. In this case, x equals 0 is my line of symmetry. Notice that x equals 0 here is the same x value as my vertex point. Okay, other characteristics. What are other things that we can think of? Are there any other important characteristics? Let's see. Oh, well, it's got an x-intercept. Okay, it's got an x-intercept. There's a point on this graph that's important to me because it's the point that touches the x-axis. We know x-intercepts happen when y is 0. So in this case, I've got an x-intercept Remember, it's a location, it's not just a number, so it's an x comma y. In this point, my x-intercept is the point 0, comma 0. Okay, it's the point in which your parabola touches, in this case, or crosses the x-axis. That's called your x-intercept, another characteristic of the parent function. Awesome. So right here, I've opened my workbook up to worksheet 6.1A to go over one more example of parabolas. So in your workbook, in section 6.1A, number 1 asks you to describe the parabola by giving or naming off some of its certain characteristics, especially these specific values, A through E. So what are those real quick? So A asks, does the parabola open up or does the parabola open downward? Okay. B asks, what are the coordinates of the vertex? Remember, the vertex is a location. It's an x comma y, so be sure to list an x comma y value. C says, what's the equation for the line of symmetry? Those are going to be x equals numbers in our case. D is the number of x-intercepts, and E are the coordinates of those x-intercepts, if there are any. Okay, keep in mind sometimes there might not be. So for number 1, for example, let's talk about number 1. The first part asks, part A says, does this parabola open up or does it open downward? Well, looks like to me that this parabola, by the way that the arrows are pointing, if that was a bowl of cereal, you wouldn't have anything left inside of it anymore. Okay, that is a downward facing parabola. So this one opens down. Okay, that parabola is a downward facing parabola. It opens downward. Part B says, what are the coordinates of the vertex? Remember, the vertex is either that highest maximum point or that lowest minimum point. In this case, our vertex acts as a maximum number. Okay, so our coordinates of the vertex, right here, that highest point looks like, in this case, it's at the value 0, 6 is a vertex. And the vertex here is a max. It doesn't ask for a max or a minimum, but I like to say that anyway, just because it's an important characteristic to notice. C says, what's the equation for the line of symmetry? Well, where is this parabola centered? Okay, so if I were to draw a line of symmetry, it looks like it would go right down the middle here, right through the middle, and that equation for that vertical line is x equals 0 once again, so equation of that line would be x equals 0. D asks for the number of x-intercepts. An x-intercept is where the parabola hits the x-axis, or in this case, intercepts the x-axis. It looks like we have 2 locations for an x-intercept here. We've got 2 of those. This one on the right-hand side looks like it's at the point 3, 0. And the one on the left-hand side looks like it's at the point -3, 0. Okay, and finally it says, whoa, hold on, we just skipped one. Sorry about that. D, number of x-intercepts. Sorry, there's 1, 2. So 2 x-intercepts, and we just answered part E by giving their location. 2 x-intercepts because it intercepts the x-axis twice at both of these blue circles. And then the coordinates for the x-intercepts, if they are any, is 3, 0 and -3, 0. Good. At this point, click to start video 2 of the 6.1A notes on my YouTube video playlist.